Okay, so what section? This is 1.3. This is section 1.3. So we're going to finish the 1.3. We're supposed to finish today, 1.3 and 1.4, aren't we? Oh, yeah, I don't think we're going to do that. I'll do the best I can. All right, find the reference angle for 263 degrees. Yeah, actually, I better finish these. All right, so what's a reference angle? So that's what we need to talk about. What is a reference angle? Reference angle, this will be important throughout the entire course, means how far to the nearest x-axis. How far to the nearest x-axis. Now, what do I mean by all that? Let me show you. So 263 degrees. Where is 263 degrees? Remember, this is 0. They decided to start 0 straight right. Just made that up. Could have put it straight up, but they decided just to put it straight right. That's 0. So straight up is 90, as you know. 180 is here. 270 is there, right? So 90, 180, 270. So where's 263? Well, I don't know. Something like about right here. So 263 ends up about, not 260, 263, ends up somewhere about there, you know, almost to 270. Good enough. I just want to get which quadrant it's in. Good so far? So 263, right to there. It's almost to 270. All right, now, what are we supposed to find? The reference angle. What is a reference angle? How far to the nearest x-axis? X-axis. So where is the nearest? If you're here, if you're right there on that line, this point, what is the nearest x-axis? Is it there? No, that's the further one, huh? So it's there. That's the nearest. So really they're asking me for this angle. I'm kind of scribbling everywhere. They're asking me for this angle right here. That's going to be the reference angle. It's how far to the nearest x-axis. Is that making sense? Yeah. If the angle had gone past 270, was over here in the fourth quadrant, then we would go this way. So we're not going to the y-axis, we're into the x-axis. The reason we're into the x-axis is because that's where they started 0. Basically, we'll see reference angles will be really important because we'll see that when you use reference angles, all the trig functions will be the same. Sine, cosine, tangent, all the rest will be the same as the real angle. I'll explain as we go on, but let's just find it for now. So the reference angle is going to be how far from where we ended up, 263, to the nearest x-axis. So how far is that? How do we figure out how far that opening, this opening right here, is? Yeah, subtract 180 from 263, right? Because this is 180, and you went past 180 a bit. How far? I don't know. Take 263 minus 180. Just use your calculator. It's 83? 83. That's the answer. So you get a 3x5 card for the exam, which is next Wednesday, week from today, right? Practice exam number 1 is already online, therefore it's under announcements. Maybe I'll show it later. Anyway, so put that on your 3x5 card if you need to, whatever you need to. Put whatever you want front and back. Reference angle is how far to the nearest x-axis. Good? Yeah?
If the x-axis is behind it, is it negative?
No, always positive. Yeah, good question. Reference angle, we always do positive. Yeah, good question. Jason, right?
Yeah.
7. So find the reference angle. Make sure I got that right. 10 pi over 7, yeah. All right, find the reference angle for 10 pi over 7. Okay. I would, 10 pi over 7. Yeah, that's what I'm wondering. I mean, you can always do that if you want. Yeah.
Don't you need to in order to get the angle?
You certainly don't have to. It's just, you got to figure out where it is, though, to know which thing to subtract it from. You know what I mean? So, do you sense where 10 pi over 7 is?
Does it want the answer in radians?
It does. It wants a radian answer in the end. So if I go to degrees, I'm going to have to go back to radians. Yeah, good question. So I'd rather not go to degrees, but I'm afraid you won't know where that is otherwise. So now, okay, how would you know where that is? Let me tell you. Yeah, look at the unit circle. Yeah, would that help? You mean that unit circle I gave? Maybe. Yeah, maybe that's a good idea. Yeah, let me grab that thing and paste it in here. Where is that thing? Come here, unit circle. Where are you? There it is. Yeah, would that help you? there's the unit circle. Can you tell where? Now, 10 pi over 7 is not exactly on that. This is what I'm hoping you put on your 3x5 card. That's the main thing. Anyway, does that help at all? Can you tell where 10 pi over 7 is by looking at that? Yeah, see, it's tricky, isn't it? Basically, here, I'll help, but I think we better change the degrees. Here's the deal. 10 pi over 7, that's 1 3/7 pi. Do you look at it that way? That's 1 3/7, right? Because 7 goes into 10 one time, remainder 3. It's 1 3/7. Remember how to change between mixed numbers and whole and improper fractions? Right? You multiply 1 times 7, add 3, that's 10/7, right? So why am I doing that? Well, that means it's a little less than 1 1/2. 3/7 of a pi is less than half, right? 3 out of 7 is just under half. So that's under, see, this isn't easy, 1 1/2 pi. But it's more than a pi. It's in the third quadrant. Why? Because this is 1 3/2, that's 1 1/2. This is 1 pi. So it's between 1 pi and 1 1/2 pi. It's about right there. So that's probably hard for you to do, I'm assuming, to kind of figure all that out. So just change the degrees. So just pop in a 180 for pi, right? Pi is 180. Just pop in a 180. So then you get 10 times 180, right? Pi 180, that's always the bridge, right, between the two worlds. 10 times 180 over 7. 257, whatever, blah, blah, degrees. So it's about 257 degrees. So like we said, see, it's the third quadrant. It's not quite to 270. So it's about right there. Okay, so I only did that. I'm not going to use the 257 number. I can't. They want the answer in radians. So I'm not going to actually use that. I just use that to find out which quadrant I'm in. Does that make sense? That's all I'm going to do. Now I'm going to go back to the 10 pi over 7. But that helps me know what I need to subtract from. Because remember, reference, again, reference is how far to the nearest x-axis. And we use x-axis, not y, because 0 degrees started on the x-axis. That's why everything's into the x-axis, because they started 0 at the x-axis. They just made that up. They could have started, anyway, so it's all based on the x-axis. Therefore, so how far to the nearest x-axis? Well, that means I need to take 10 pi over 7, because this angle here is 10 pi over 7, right? Right there. And I need to subtract 180, but I can't subtract 180 because that's degrees. So what do I subtract instead?
7 pi over 7?
Just make it pi, yeah, which is 7 pi over 7. We make it nice. Yeah, so 10 pi over 7 minus pi, because 180 is pi radians, as you know. Does that make sense? So it's the same thing as the last problem, it's just in radians. So I'm going to 10 pi over 7, and I'm wondering how far is that past pi, because there's pi, and I want past it to 10 pi over 7. Right? So subtract those. Yeah, make that 7 pi over 7. That's just a fancy 1 pi. So it's 3 pi over 7. That's the reference angle. That's how far to the nearest x-axis. Did you track with that? So I took 10 pi over 7, and I subtracted 180. But instead of subtracting 180, I subtracted pi. That is 180. But I had to make it common denominator. So I could subtract fractions. So I multiplied top and bottom by 7. Yeah. Yeah, because those are both third quadrant, huh? Yeah, it'd be good to do. Negative 160 degrees. So try that one. You can use that unit circle if you want, or just draw your own thing. Find out. Basically, you got to find out which quadrant it's in.
Does the negative matter?
Yeah, good question. Negative does. So positive, so zero's right here. And positive angles start going up, negative angles start by going down. So negative, we're going down first. So we're going down. So this would be down 90. Keep going down. This would be down 180. So where are we? About right there. Again, the third quadrant. There's like all the third quadrant. I guess we won't do a different one. They're all third quadrant.
So do we always subtract that side?
No, oh yeah, actually this will be a little different. Yeah, let me help. So everybody good so far? So, right, everybody see what we're doing. So, negative 160. Negative 160 is right there in the third quadrant. Okay, now, the question is, what is the reference angle? Remember what reference angle is? How far to the nearest x-axis? That'd be like if I said, how far, for each of you, how far to the nearest door? And for some of you, it would be how far to that door. For some of you, it would be how far to that door, right? So that's what we're doing. Reference angle is how far to the nearest x-axis. So that'd be that, right? That's going to be that's the nearest for him. That's, again, the nearest. So how far is that?
180.
That's how far is my question, right? So 180 is what the door is. How far is it?
Negative 20 degrees.
If I said, hey, how far down to L.A.? I'm going to L.A. this weekend. That's not true. But anyway, sometimes that is. We have family down there. But anyway, if I said, I'm going down to L.A., how far? Negative 200 miles because it's south. Negative. Nobody talks that way. How far, distance, is never given as a negative answer, is it? It's never done that way. Same thing here. 20. Makes sense? We don't give a negative answer. The fact that they say reference angle is distance, how far to nearest, means you only give a positive answer. That's not really a math thing. That's just a common language thing, huh? That's what we do with the word distance. We could have given negative answers, but we don't. So, yeah, the reference angle is 20 degrees. It's 20 degrees to the nearest x-axis. That's how far, that's distance to the nearest x. We never give it negative, just like distance. Did I answer your question? Yeah, it's never negative. Reference angles they're a distance. Reference angles are how far to nearest x-axis. Distance, so always positive. Just like we communicate distances in the real world. Always positive. Find the reference angle for 1.9. 1.9? I'll give you a second. That one's pretty tricky.
It's not 1.9 degrees, it's just 1.9.
Really good question. Really good question. Presley, right?
Yeah.
Presley. Presley's question, is that 1.9 degrees or what is that? Really good question. That's kind of the most important first question. What do you think? Is that degrees or radians?
Radians.
Yeah, it's got to be radians because they don't have a degree symbol. Yeah, you want to think the following thought carefully. That is because you can tend to get in the rhythm like, hey, if it has a pi, it's radians. That's not true, though. It's just what they typically do. But that's not the rule. The rule is if it has a degree symbol, it's degrees. If it doesn't have a degree symbol, it's got to be radians, whether it's got a pi or not a pi. So this is radians, right? So it's radians because they didn't put a degree symbol. So good question. All right, so we know that's radians. Well, then where in the world is that thing? So the first thing you got to do is use your calculator, do whatever you need to do. I would change that to degrees because you have to find out which quadrant it's in, right? It's all about finding where that thing is so you can find out how far to the nearest door, how far to the nearest x-axis. So go ahead and convert that to degree, unless you just know, unless you just like feel radians, but I know most don't. So 1.9 radians, how do I convert to degrees? Remember, it's the 180 pi thing. That's always the bridge between the two worlds. But remember we talked about how chemistry, at least that's where I learned how to do the unit thing. Which way do we do it?
180 over pi.
Yeah, because you want radians to be on the bottom. Because this is over 1. You want radians to go away. That's what I learned in Chem 3a. Yeah. Right? It's about getting units to go away. You want so you put below what you want to cancel, radians, and you put up here degrees. So it's 180. You can just write degree symbol. You don't have to write the word degrees, whatever. Over pi radians, huh? That makes sense? You know which way to do that? So you use calculator then. So whatever that is, 1.9 times 180 divided by, and use your pi button on your calculator. And I'm getting 108, whatever, degrees. Good enough. I just need to know basically where that, I'm not going to use the 108 degrees. I'm going to have to go back and use the 1.9 when it comes to actual calculation. But 108, so this is 180, this is 90, so it's, I don't know, it's somewhere about right there, huh? Second quadrant, right?
Wait, how did you get 108?
I just took 1.9 times 180 divided by pi on my calculator.
Okay.
And just multiply the top numbers, divide the pi. Anything on the bottom, we just divide.
This is round to the nearest hundred. Oh, okay.
Yeah, the radian answer, we will. So, okay, so we know where the angle is. It's here in the second quadrant. So reference is how far to the nearest x-axis, which would be there, huh? We good? That's the reference angle. It's the opening between those two. An angle's an opening between two lines, right? So the reference angle is the opening from there to the nearest x-axis. So how do we find that out? Now, we can't use 180 because we're going to go back and use the 1.9. We're not going to use this 108. That's not the real value. We got to give a radian answer. That just helped us find it. So 180 is pi radians, as you know. So what do I got to do then? Pi is all the way there. Pi minus the angle. Does everybody see that? Because it's pi back up a little bit, isn't it? Right? It'd be like if I turned all the way to pi and then back up a little bit. So it's pi minus 1.9. That's going to be the answer. Just use your calculator. Use the pi button because you got to be exact. You can't just use 3.14. You got to be more exact than that. 1.241. I don't know how many decimal places they want. Let me see. I can see if I look back at the answer thing. They want, well, it's off that screen.
If we don't put the pi sign, the pi at the end of our answer?
So there's no pi on this answer.
No?
No. So the answer is just the 1.24 on that one. Just 1.24.
Is that just because the question doesn't have a pi in it? Or, so like if it was 1.9 pi, would we have had to put a pi symbol at the end of the answer? Remember, pi's a number. I know we can get kind of mystified by the pi thing. Pi's just a number, huh? It's just a special number. It comes from whatever. I won't go into that. But it's a special number. It's a special number, and so it's just a number. So they just want a number in the end. So no pi. No pi. Right, because the other one we did with radians, we didn't have that, right? Let me see, where was that? Oh, wait, what in the world just happened? It was number 11.
Oh, there we go. Yeah. That one did have a pi. Oh, did they want a pi? Maybe I did that. Yeah, so this other one they did want a pi. Yeah, they did. And this one, yeah, I guess it's because it didn't start with a pi, huh? Didn't start with a pi. Yeah. On the test, it's multiple choice, so it won't be a problem. The homework, just click until you get the answer. Yeah.
So the problem on my math Excel, the degrees got me to 756.
Yeah. Subtract a couple 360s, right? Whenever you're more than 360, so take your calculator, subtract 360 twice there, and then you'll find out what quadrant you're in on that.
The last question I had fine, it was asking for a fraction. This one was not.
Oh, is that what it was? Maybe it's when they asked for fraction. Yeah. I better move on. Just with Math Excel, just if you're ever unsure, answer 3 times, get it wrong. It'll tell you see whether it wants a pi or whatever it wants, then just ask for a new one. Test, multiple choice, won't be a 6. Okay, let's try that one. That one's going to be like way more than 360. So go ahead and stick in your 180, change it to degrees. You'll find out it's huge. It'll be like, I don't know, 5,000 degrees or something. And then you got to subtract a bunch of 360s, right? Take out the full circles because you got to find out what quadrant it's in. So I'm going to stick in a 180. 53 times 180 over 6. Hit the buttons on your calculator. I'm getting 1,590 degrees. And like that's way more than a full circle, huh? That's way more than 360. So just start subtracting 360 however many times it takes until you get a number that's under 360. I don't know. I'll just keep going. Minus 360. Minus 360, minus 360, minus... I did 4 times, and I got 150 degrees. I subtracted 360 4 times and got 150 degrees, and so then I can put it on there. Where's 150? Well, this is 180, this is 90, this is 0, so 150 is about right there in the second quadrant, huh? We good there? Oh, I see. No, this one's a little tricky. Yeah. Yeah. Okay, yeah. So one, let's just answer in degrees. Yeah, so what, and then we'll go back to radians that way. So what would be, is everybody good to hear so far? We okay so far? I just plugged in the 180 for pi, got a whopping answer, subtracted a bunch of 360s, 150. Now, in degrees, what is the reference angle? How far to the nearest x-axis? Yeah, right there, the reference. is 30 degrees, isn't it? Let me bring that over here. So the reference, at least in degrees, is 30 degrees. Now we have to change that. This would be the easiest way. Change that. Now, well, let me do it first. I'll explain why. Change that back to radians. So how do we take 30 degrees and change to radians, because they want a radian answer?
Pi on the top and 180 on the bottom.
Yep, got to get degrees on the bottom because you want degrees to go away, like I learned in Chem 3a. Right, you want to cancel out degrees. Put this over 1, like that. And that is 30 pi over 180, or you could just cross cancel those, huh? That'd be the easier way. 30 go there, 6. So pi over 6 is the answer. Now, is that good to there? I want to explain why I didn't do something else. Does that make sense? Why didn't I just do like I did on the other problem and just say, as soon as I saw what quadrant here in the second, just take the whatever it is, 53 pi over 6, and just like subtract from pi or whatever.
Because your starting point is above.
Yeah, because from here to here is not 53 pi over 6. 53 pi over 6 is around and around and around and around and around. It's not just right there. Does that make sense? So if it's a whole bunch of roundy rounds, then you can't use the 53 pi over 6, right? You've got to do the degrees and change back. Does that make sense? That's why it's different than the last problem. Yeah.
If we're ever confused on like say on the exam we're confused or we just blank right quick second how to do the radians thing. Would you get the same answer if you did it this way, like doing it completely in degrees and then changing it to radians?
Yeah.
Okay.
Yeah, right. If you choose a bunch of accuracy, yeah, that's the only thing. If you long as you use enough accuracy, just change it all in the end. Yeah, that'll work.
Okay.
That'll work. Find the reference angle. Getting scribbly there. Find the reference angle for negative 17 pi over 4. So yeah, just convert to degrees. Find out where it's at. So pop in the 180. So 180 divided by 4 times 17. I'm getting negative 765. And then what do you do to convert that into like a more normal? That's a huge negative angle. Now we add 360s, huh? So add 360, add 360. You could just do two. Let me show you a trick. Add 360, add 360. Whoops, I did the wrong thing. Negative 765 plus. And I'm getting negative 45. Now, you could do another, but hold on for a second. In the end, I just want to find out where it's at, right? Mm-hmm. So at this point, I know where that one's at. Negative 45. That's down 45 degrees right there, huh? Mm-hmm. Is that good so far? You with me? So you can always add or subtract 360s, and that's a full loop, right? Mm-hmm. So like if I'm facing the door and I turn 360, I'm facing the door again, right? So if you add or subtract 360, you end up facing the same point. So any angle, we can add or subtract 360. We haven't changed anything. We're still facing the same point. Okay, so I'm at negative 45 now. That's good. If you think, well, can I add another 3? You could, but why? I know where I'm at right now. It's just all for us to find out where the thing is at, and I can tell now, negative 45. So here comes the question now. What's the reference angle? How far to the nearest x-axis? 45, huh? It's right there. There's the nearest x-axis. The reference must be, and it's positive, right? Because it's a distance. Just like if I go south or I go west, we don't say negative because it's south or west. We just say the distance, and we just say positive. That's what a reference angle is. It's a distance. So how far to the nearest x-axis? Well, if you're down 45, it's 45 to the nearest x-axis. So, but we got to change that back to radians in the end, huh? You know how to do that. Put the 180 in the bottom, the pi there, divide. I think that goes in 4 times. Pi over 4. Done. Good with reference angles? Questions I can answer on that one? All right, if I was too quick, it'll be on you. Okay, so now now that we're going to go back to actually finding trig values like we did last time, we're going to use the unit circle. So these kind, no calculator, these kind will be on the exam in a week from today. Remember, exam will have part 1, part 2. Part 1 will be no calculator at all, but you can use your unit circle, right? You have your 3x5 card, and you'll have your unit circle written right on there, or whatever you want to do, but something written to help you find the angles. And then part 2, you can use your calculator and everything. But anyway, so my point is you should be able to do this without your calculator just by using the unit circle. So let's do it. So first off, what are we going to do with that 5 pi over 4? I would probably convert that to degrees, unless you're really comfortable with radians. I don't know. Probably most aren't yet. You will be by the end of the semester, more comfortable anyway. Here, I'll just tell you, I don't know if this works for anybody, but yeah, you can look here at the unit circle chart. There it is. See, this is pi over 4. Pi over 4 is a quarter way. So this is 1 pi over 4. Well, here, let me get a new one that's not written on.
If you follow the line to the opposite side.
So this is 1 pi over 4, 2 pi's over 4, 3 pi's over 4, 4 pi's over 4, 5 pi's over 4. If you just know pi over 4 is going a quarter way. It's 1, 2, 3, 4, 5 pi's. So there's 5 pi over 4 right there. Remember how, so we got, here's the x and the y. Now, x is what? Cosine or sine? Cosine. This is cosine. This is sine. They're both negative root 2 over 2. So what did they want on this one? They wanted cosecant. So let's go back. So we have at 5 pi over 4, the cosine is negative root 2 over 2. The sine is as well. And what they want cosecant. Now what's cosecant? Do you remember? Upside down of sine, huh? It's 1 over sine. You just take sine and you flip it. So that means you just flip. Oops, I didn't do a very good job. Let me rewrite that. You just take this sine and you flip it like that. Is that good? Now we can't leave the root in the bottom. I'll fix that, but so far so good? Cosecant's just upside down of sine. How do you get rid of that root from the bottom? Multiply top and bottom by root 2, right? Remember that from algebra, to get rid of roots? Just multiply by that. Minus 2 root 2 over plane 2, right? 2 root 2's make a plane 2 in the bottom. They cancel. Final answer, minus root 2. Didn't need a calculator. 2 in 1 out? Oh, yeah. Right, yeah. Yes. 2, yeah, sorry, I forget. That's right. That's the word I always use. 2 2's in, 1 2, yeah. So when you have the, like root 7's plane 7. Root 5, plane 5. Root 2, plane 2. You good with those root rules? Remember those? 2 of the same root make 1. Yeah, 2 2's in a root sends 1 2 out of the root. That's the algebra rule. Yeah. So we good there on that? So I think you can do that. Negative 330. So yeah. So what do you do with a negative 330 angle? I'd probably just add 360 to make it easier. I just like positive angles myself. You don't have to. If you can find, basically you just got to find where it's at. Whatever's easiest for you to find it. I think it's easy to add 360. So what angle is that really then? That's 30 degrees. That's going to be the same place as positive 30, isn't it? Remember, whenever you add a full loop, add 360, you're facing the same point in the end. Same direction in the end, I should say. So now, you can go to the unit circle picture. You know what would be better for you? If you drew them yourself every time. It really would. So 30 degrees, remember how we just, you could look at that unit circle picture. I know that's quick. But really, remember where 30 degrees is? 45 is the middle. 30 is right here close to 0. So this is 30 right here. And then we talk about how far over and up. Remember that to that point? So there's 30 degrees. It's close to 0. How far over? Remember, it's small, medium, large. Remember the 3 numbers? It's 1, root 2, and root 3 over 2. That's the small, medium, and large values. Remember those? Small, medium, and large values. And so this one is over a lot, up a little, huh? Over the large, over root 3 over 2, up only a little, up only a half. Remember, the small and the large always go together, and the medium is only used in the middle of each quadrant. Remember that? The medium goes with medium. You know, medium doesn't mix with small and large. Medium with medium only in the middles. And at the other points, like at the 30 and the 60, that's where you have the small and the large, huh? At the 45, that's where the medium goes with medium. Anyway, so remember, the x is cosine, the y is sine. It's reverse order, right? Cosine comes first, sine. They just made it up that way. So the cosine is the x, that's over root 3 over 2. The sine is the up half. What do they want? They want sine, so the answer is a half. It's this one. Is that good? Don't need a calculator, right? Just put this on your 3x5 card. You probably should put the whole unit circle. That'll be easy. All right. Good questions there? Do those. Easier than reference. Okay. So they want us to like figure 4 of those out and like put them all together. Kind of a mess. So let's see. So 15 pi over 4. I'm going to stick in a 180 there for pi. And a 180 there for pi. And so this will become the sine. Use your calculator. 15 times 180 divided by 4. That's 675 degrees. Cosine of 60, bless you, plus cosine of 675 sine 60. Good. I just changed it all to degrees by popping a 180 in for pi, like we always do. Now 675, let's subtract our 360. What is that? So that's going to become 315. 315 degrees. Good there. Sine and cosine of 315 degrees.
Why did you simplify it?
Because it's more than 360.
Oh.
Right? Whenever the angles are more than a full loop, I always subtract. I subtracted 360 there. And I subtracted 360, right? Whenever an angle is more than, so it became 315. More than 360, we subtract 360s until we bring it down to something easier. Good there? So now in the interest of time, I'm going to go find the sine of 315 degrees. Can I do that in the unit circle here real quick? Where's 315 degrees?
Quadrant 4.
Yeah, it's right there in the middle. 315 is right there because it's 45 from 360, isn't it? So it's right there in the middle. There's 315. How far over and how far down to that spot? Remember the small, medium, large. If that's right in the middle, it is because it's 45 from 360, huh? If you add 45 to that, it'd be at 360 all the way around. So that's right in the middle. So small, medium, or large?
Medium.
Yeah, the middle is always medium with medium, huh? Yeah. So that's over the medium. What? Remember the medium is the 2. It's 1, 2, 3. 1 is small, 2 is medium, 3 is large. 1, 2, 3. What could be easier, huh? Right and down, huh? See, positive and negative, right? Right and down. Does that make sense on that? So this dot right here, the cosine is always the x, the sine is always the y, isn't it? On the coordinates. Put the coordinates here. This one is over root 2 over 2, down root 2 over 2. Cosine is the x, sine is the y. So they want what? Sine of 315. That's right here, negative root 2 over 2. And this one is cosine of 315. That'd be regular root 2 over 2. So let me rewrite that in a fresh screen here. Was it just start with sine? Yeah, sine 315. And then I got to do the 60-degree angle also. Sine, cosine, cosine, sine. Okay, so the sine of 315, what was it? So it's negative root 2 over 2. And the cosine of 315 is positive root 2 over 2. Good so far? Just popping those in. Now let's do the 60. Where's the 60-degree angle? Let me get rid of this. 60 would be, here's 90. So 60 is almost to 90, isn't it? So let's think about, like, you know, over and up to get to that 60-degree angle. I'm trying to find the cosine of 60 and the sine of 60. So to get to 60, which is almost to 90, over a little bit, up a lot, huh? So small, medium, large, 1, 2, 3. So it's over how much? 1, yeah, small, 1. And it's up. Oh, not root 2, it's plane 2, huh? What am I doing? It's over a half, up root 3 over 2. Are we good with that? It's because it's, you know, 1, 2, 3 on the top and just a 2 on the bottom. So it's over. So this point is over a half, up root 3 over 2. This dot right here is over a half, up root 3 over 2. And this is cosine is x, sine is y. So for cosine of 60 degrees, it's a half. Sine of 60 degrees, it's root 3 over 2. Let's put it in. Cosine of 60 is a half. Sine of 60, root 3 over 2. And these are times, aren't they? And there's a plus in the middle. Everybody see how I found that? Just put on unit circle. Now, of course, you could go to this unit circle and find them there too, right? There's your 60. There's your cosine. There's your sine. Here's your 315. There's your cosine. There's your sine. I just wanted you to see them drawn, though. I think it's helpful just to see it. Anyway, there we go. Now we just got to put this together. Good so far? So how do we multiply two fractions? Just straight, huh? Top, top, bottom, bottom. So minus root 2 over 4, right? Just root 2 times 1, 2 times 2. Good. And then here, root 2 times root 3, root 6, 2 times 2, 4. Just straight, top, top, bottom, bottom. And now they already have a common denominator, so just put them together. Done. So you just make them one fraction because they have a common denominator. I can't subtract these, by the way. I don't know if you remember those rules from algebra. You cannot take root 6 minus root 2. They just stay separate. They're unlike terms. Roots must be the same number to add or subtract them together. If they're different, they just stay separate. So that's just it. If it bugs you to have the negative in the front, you can move to the back. The order doesn't matter. But that's the answer. Is that good? Questions on that? All right, that's a pretty tough one. That was number 23 there. That's probably the hard. All right, so 24. I'm just going to scribble it in up there. There's the answer and everything. How'd they get that? Well, see what they're saying up here in 24? Well, maybe it would be helpful to rewrite it a little bit. They're saying f of x is sine x, and they want f of 5 pi over 3 minus pi over 6. What they want? Plus f of, boy, they want everything. Plus f of 5 pi over 3. Minus f of pi over 6. All right, they want a lot. Okay. So they're giving me that function. Awesome.
What's the first one?
That's a 5 pi over 3, yeah. My 5, sometimes something looks really weird, for me, it's usually a 5. I can't make 5s. I'm 5 challenged. So if it looks weird, it's a 5 probably. 5 pi over 3. All right, so what do they want me to do? Well, basically, they're bringing in function talk. They're just trying to get you more comfortable if you're moving up the line to pre-calc and calc and stuff. So once you get more and more used to functions, that's all they're doing here. Basically, the function is sine. So in other words, this is just sine. If you want to just put a sign there, that's all that's saying, right? This says the function is sine. So when they say the function of this angle, it means the sine of that angle. They just want you to make sure you're comfortable seeing function language. But practically, it doesn't mean anything other than take the sine of those guys. Okay, so how do I take the sine of this right here? Well, first off, I have to combine those fractions, don't I? And then I'll just go to the unit circle. So how do you subtract 5 pi over 3, take away pi over 6? Common denominator, huh? So that means multiply top and bottom of this one by 2. So that'd be the sine of, what is that, 10 pi over 6 minus pi over 6. The other ones, I'll just leave them. I don't need to do anything with the other ones. They're good. I mean, I'm going to go to unit circle in a minute. But, so then subtract these two. What do you get? 9 pi over 6 when I subtracted those two. Okay, so 10 pi over 6 minus 1 pi over 6 became 9 pi over 6. And what do you do with 9 pi over 6? You got to remember all fractions that can be reduced, you always want to do that. So if I can divide top and bottom by, what, 3 there? It'll become the sine of 3 pi over 2. And the other ones are still just waiting. Good there? Now let's just go to the unit circle. So go to the unit circle. I'm going to find all these angles. Get my unit circle up here. Okay, first one is 3 pi over 2. 3 pi over 2 is down here. There's 3 pi over 2. And can you tell there's cosine sine? So the cosine, remember, they're backwards order. Cosine's first, then sine. So sine of 3 pi over 2 is -1. So that one's -1 plus. Now I want the sine of 5 pi over 3. Go to the unit circle. Where's 5 pi over 3? Thought I saw. Oh, there it is. Right there. Cosine sine. We want sine of 5 pi over 3. I don't know if you can read that. It's -√3 over 2. So -√3 over 2 minus. And now we want the sine of pi over 6. Pi over 6. Right there. Cosine sine. Sine is 1/2. Okay. Good to there. Now we got to do something with those guys. Yeah, they won't take the answer that way. So to put them all together, I got to make common denominator 2, huh? You know what you could do? Make that -1 into -2 over 2. That just makes common denominator. Is that okay what I did there? That's still a -1, isn't it? 2 over 2 is 1. But now they all have the same denominator. So I can combine them. So putting that all together, what do you got? -2 minus √3, -1 all over 2. And then -2 and -1, -3 minus √3 all over 2. There it is. It's as simple as it can get. Is that too quick at the end? So that -1, let me write that again. That -1 I converted to -2 over 2. And then I just put the tops together. I just said -2, -√3, -1. Right? -2, -√3, -1, all over 2. And then I combine -2 minus 1 to be -3. We're done. It's a lot of work there. But in the end, it was just combine and go to the unit circle. All right, 20. That's what they're doing. They're getting you ready for rate of change. So let me just give you the simple thing. Rate of change is slope. It's basically a fancy way to do slope. Rate of change is slope. You ever thought about it for a second? Whenever you have a rate, like if you drive your car at 50 miles per hour, think about that for a minute. That's a fraction, isn't it? 50 miles per 1 hour. That's what that means. It's a fraction. You go 50 miles every one. If you hold it steady at 50 miles an hour for 1 hour, you'll go 50 miles, won't you? How fast you do Math Excel homework. I can do 10 problems per hour. That's a fraction, isn't it? 10 problems per 1 hour. Right? I can, any rate, anytime you talk about how I can grade 12 papers per minute. Well, that'd be amazing. So whenever you do a rate, time's on the bottom. That's what it means to do a rate, how fast you do something. We're doing a little physics here, aren't we? Rates are fractions. Rates are fractions. And slope is also a fraction. Remember slope from your algebra days? What was the equation for slopes? Anybody remember that? Well, that's the equation of a line. How do you find slope? y2 minus y1 over x2 minus x. Remember the difference of y's over difference of x's? That's how you do slope. Well, slope is a fraction, and slope is therefore a rate. That's the connection they're wanting to make, and you go crazy with that in calculus. So anyway, long story short, we're not doing calculus here. Let me just keep it simple. They want the rate, which means they want the slope. So how do you do the slope? Well, x2 minus x1 on the bottom. There they are. There's x2 and x1, so x2 goes first, and then x1 goes after. Okay. And now, what do we do on the top? y2 minus y1. Now, I don't see a y. I see my x1 and my x2. That was obvious. What's my y1, y2? What are those? Where are those? How do I get those? Well, they gave me this function. Do you know, it's an important thing to know if you're especially going higher in math, function values are y values. That's what they are, by common agreement in the math science world. When you plug something into a function and get an answer to come out, that is a y value. They've defined it that way. So when they're asking me for y values here, you should think y values, they want function values. So y2 is going to be f with x2 plugged in. And y1 is going to be f with x1 plugged in. That's what they're really saying there. This is f of x2 minus f of x1. That's what a y value is. It's what you get out when you plug in an x value to a function. Y values are function values. So let that sink deep. That's used a lot in pre-calc and calc. Y values are function values. So when they want y values in the top, they want function values. So the function value for y2, plug in x2. Function value for y1, plug in x1. To what? Well, to the function, which is sine. So that means this is sine of x2, And this is sine of x1 because they told me the function sine. They could have made it cosine. They could have made it tangent. They could have made it log. They could have done anything. But they said the function is sine. So when I plug into the function here, I'm plugging into sine. Because they said the function is sine. So sine of x2, well, what is x2? Yeah, right there. So they want sine of pi over 2. And here they want sine of 5 pi over 4. Is that making sense? So slope is difference of y's over difference of x's. So that is sine of the sines, the difference of the sines over the difference of the x values. So now we go to the unit circle, find the sine of pi over 2 and the other one. Find those. And we are done with that one. All right, so sine of pi over 2, let's go to the unit circle. Pi over 2, wherever that is. Pi over 2 is right here. Here's the cosine and the sine for pi over 2 up there. So the sine is 1, right? Sine of pi over 2 is 1 up there. So bring this over here. This part, sine of pi over 2 is 1. Now how about the sine of 5 pi over 4? Where's that one? Here. Cosine sine. Sine is negative root 2 over 2. Whoop. Negative root 2 over 2. On the bottom, we've got pi over 2 minus 5 pi over 4. You tracking with all that, with what I did there? So rate is a slope. Difference of y's over difference of x's. That means difference of function values over difference of x's. Now I just got to work this out, which is easier said than done. So how am I going to do this? First off, what are these double negatives going to do?
Positive.
Going to be positive, right? Because we had subtraction, difference, but then the second part came out negative. So it's going to be 1 plus root 2 over 2. And what do you do without 1? Make it 2 over 2 for common denominator there on the top. On the bottom, same thing. Got to get common denominator, Make it 2 pi over 4 minus 5 pi over 4. This one's a mess. Okay. I'm going to go to fresh screen if that's okay. 2 over 2 plus, what was it? Root 2 over 2 over 2 pi over 4 minus 5 pi over 4. And so that combines together 2 plus root 2 over 2 over 2 pi minus 5 pi is minus 3 pi over 4. Is that good to there so far? This is a messy problem. We're almost there. What do you do when you have like a fraction on the bottom of a fraction like that? Dividing is upside down multiplying. You familiar with that? Right? So this is divided. Right? You know what I mean? If I take 10 and divide it by 2, I get 5. If I take 10 and multiply by a half, same answer, Half of 10 is 5, or 10 divided by 2. So dividing by a number is the same thing as multiplying by the upside down. Multiplying is upside down dividing, or vice versa, dividing is upside down multiplying, aren't they? So when you're dividing by this, that's the same thing as multiplying by the upside down. The reciprocal. Have you seen that before? So you just bring this up upside down. You just make it multiply, make it times the upside down, because dividing is just upside down multiplying, isn't it? So therefore, that'll make it easier. So then what we have is 2 plus root 2 over 2 times 4 over minus 3 pi. Do you remember all this algebra? Doing a lot of algebra here, aren't we? This is really valuable if you're wanting to go higher. It's all about algebra. 2 goes into 4 2 times. So we end up with 2. Remember cross canceling there? Times 2 over negative 3 pi. There we go. You could distribute this too, or leave it. I don't know. This is fine, or if you want to distribute it, you can. It doesn't really matter. Both those are good. Both those are good final answers. Either one. They probably went there.
Yeah, the Mac they want it, I'm afraid.
They want it this way? Yeah.
Well, you'll take both of those answers.
Multiple choice on the test.
Oh.
So see either one, grab it. They're both good. Good on that? A lot of steps to that one, huh? So I didn't want to do that one. It took forever, but I guess. Find two values. Find two. So we're on number 26. This is it. 27 is the same exact question. It might change the numbers for you. But basically, they want me to say, okay, sine of some angle, theta, is negative root 2 over 2. Find two values for theta. So I'm just going to go to the unit circle and look at the thing. It's all this is an easy problem. Just go to the unit circle and look and find where sine is negative root 2 over 2. So here we go. Go into the unit circle. Our favorite little tool. Whoops, that's not the unit circle. I clicked the wrong thing. Come on. There we go. All right, so there's the unit circle. As you look around, remember it's cosine sine, cosine sine, cosine sine, cosine sine. Bring it down here. Cosine sine, cosine sine, cosine. Where, as you look around this thing, it's always cosine first, then sine, all the way around this thing. Where do you see a sine value, two places, where sine is negative root 2 over 2? Here, 7 pi over 4, and 5 pi over 4. Everybody see that? Sine is negative root 2 over 2. Sine is negative root 2 over 2. 5 pi over 4 and 7 pi over 4. Done. That's all they want. 5 pi over 4, 7 pi over 4. I assume they want radian probably. If they want degrees, give them that. We